Hi everybody, my name is Max Maker, and in this week's video I will show you how we built a whole concrete slab for my dream workshop. So we're going to show you the insulation, the waterproofing, the rebar, the radiant heating system, and of course the concrete pour, including the polishing. So stay tuned for that. So this just arrived. It's a giant shipment of foam. This is the Yakudur Atlas system by the company Yakon, and this is insulation that you need underneath your foundation. But before we could install this, we had to prep the ground, and that meant leveling everything really perfectly. So we went at it meter by meter, removing or adding some dirt until it's one smooth plane, just like an ice hockey rink made out of sand. So they put down these aluminum tubes, they leveled them with a spirit level and also with a laser to make sure it's at the right height. And then they pulled a screed across the sand to finally level it, and they even used the spatula to add some more sand where there were some voids underneath it. And this was a very tedious process, but I think it's worth it because we want the insulation to be well supported, otherwise gaps could form once the concrete puts its weight on top of it. A geotechnical engineer also stopped by to do some final tests on the compaction rate, and that was all good. This is a little pocket in our concrete slab, and that's going to receive a hydraulic scissor lift. So we have a nice workbench that's height adjustable, so that's why this whole area is lower. And we have the insulation here, the Yakudur, and on top of that we have the Gifficon from the company Giffinex. This is a waterproof membrane. These are some pre-made things for the corners, and this stuff is going to waterproof from the damp ground towards the concrete, so the concrete isn't even getting wet from underneath it. And right now it's full of water because it has been raining so much, but you can see it's really nicely waterproofed. Giffinex also sent me these collars for the pipes so we can seamlessly integrate the waterproofing into our membrane later on. But that will be in the second part of the video. First we put some concrete into the scissor lift because we have to do this first, otherwise we can't keep working on it. It's just one of those things that you have to do in order. And then everything was finally leveled and prepared to receive all the foam. And this was a very exciting day because we got so much done that day. The whole building will rest on this foam, so this is almost like the foundation. I mean, we are pouring concrete on top of this, but this supports all of the concrete. On the top surface, this is super hard, but on the inside, it's rather soft. And I want to give a special thanks to the sales representative Heiko from Yakudur for coming by and showing us how to install the system. And the reason why I chose the Atlas system from Yakudur is that it's so easy to install. The company sends you these pre-made blocks. They are CNC routed, they are very accurate, and you just have to place them on the floor and stick them together, just like building blocks for kids. It's really easy. It's still a lot of time that it takes. You know, this is a big workshop. It's 600 square meters, so it's a lot of labor involved to put all of this down. But it's easy and it's something you can definitely do yourself. For the corner, they have corner pieces, and for the perimeter, they have these perimeter pieces. So the bottom goes on the floor, and then the top ones get stuck into these grooves. And these are routed really precisely. It's just a great fit. You can push them in very easily. You have to slap them a little bit to get them to seat down all the way to the bottom. But after that, they just stick in there. They don't come loose, and they're very solid. The cool thing is you don't need any shoring if you use this system. So you don't need to cut any wood or pound any stakes into the ground. You just assemble this, and then you have the concrete forms in which you can pour the concrete, and you can be sure that they will hold up and give you the right dimensions at the end of the day. Because if this foam wasn't stiff enough, it could buckle outwards once the concrete pressure hits it, and that would cause so many problems down the lines. But this is very stiff material. I mean, it's not comparable to any of the foam that you know from packaging. This is very, very stiff. It's also quite a lot heavier. I mean, it's still foam, it's lightweight, but it's heavier than it looks like. And you can just cut this with a hot wire cutter or with a saw. I just don't like the noise that it makes when you use the saw. And then we continued for the whole morning just laying down the perimeter. You just stick the pieces together, one after another, and it's really a logistics game, and it's a very easy job. It's still labor involved, but it's very easy. And once everything was stuck together, we then aligned everything to the string lines. And then we started filling in the inside. You take a box, you open it, take out the 3 pieces, and you put them on the ground. It's that easy. And we did that 1,200 times. The foam is 12 centimeters thick, and I think it's a very good investment if you have the money to spend on this, of course, but it will pay out in the long term. This will save a ton of energy every single year, and it will keep doing that for decades without having to do any maintenance on this. So I think this is much better invested than in a more efficient heat pump or anything like that. If I didn't have this insulation, I would definitely need a second heat pump, and that would cost just as much as this insulation does. But a heat pump would have a much more limited lifespan, while this stuff will still be working in 30 or 40 years. I think it's much better to reduce the amount of energy that you lose to the surroundings than into spending money into producing that energy. The last step was to add these little hooks. They just get placed on the perimeter, and then you push them down with your feet. That's very easy to do. And they tie the perimeter pieces to the first layer of foam on the ground, and that will stop it from moving outwards once the concrete adds pressure. There were some gaps in the foam where we had to cut off the tongue and grooves so the panels wouldn't match up perfectly anymore. And also where we pushed through the pipes, there were gaps, of course. And they were filled with this spray foam. This is also from the company Yakko. So it's one system, they send you everything. And they did a really good job to make sure that we have everything at hand that we needed to finish this job. We cut off the excess, and next we continued installing all of this waterproofing. So this is the area of the scissor lift in the middle. And this will be tied into the rest of the system. So this is a really easy to install and very waterproof system by the company Gefinex. It's called the Geficon system. They have different systems for different applications. But we're going to use this to stop any of the moisture from the ground to getting to our concrete slab. Because moisture is always your enemy when you're building anything. You don't want any rain in your building. You don't want any moisture from the ground. And the Geficon system is a good insurance for that because it forms a waterproof seal between the ground and your concrete. And it's a ecosystem. They have the glue, they have the small pieces for the corners. They have actually pre-made corners, which is very nice because otherwise how would you seal something like this up? You could only smear some glue in there. And it is very easy to install. And the texture of this is very rough. It almost feels like a fabric or like a felt. Not like a smooth piece of plastic, like a mylar sheet. And the good thing about that is that it actually bonds to the concrete. It sticks to it, and that's forming the waterproof seal. It is lightweight, but it's also very tough. I cannot rip this material, even if I try really hard, only with a screwdriver or something like that. And that's also the great advantage over using just a piece of plastic, because once you have a rip in that, you lose the waterproofing, and then you could have issues later on. And you really don't want any waterproofing issues underneath your slab because you can never get to it. So I think it's worth it spending a little extra money for something like that, just to have the peace of mind that you will never have water issues from the ground. In the past, you would have used a tar-based product, but the drawback with those is that they are toxic. You know, they release fumes. If you have them inside of your home, you always have those fumes, which cause cancer, which is not great. And also, while you apply it, it really smells bad, and you get a lot of fumes in your lungs. You don't want any of that. This is just the future. It's much easier, it's convenient, and it's also lightweight, and you don't have dirty hands when you apply it. They had great customer support, and I want to especially thank Volker from Gefinex for coming by and giving us some tips and tricks on the installation. We rolled out about 3 sheets at a time, and then we weighted it down with these concrete standoffs that will support a rebar later on. And then we came up with this cool system where one person would hold up the edge with a stick, one person would take off the protective film, and the third person would press down the sticky tape. And that way nobody has to get on his knees, and that really saved a lot of muscle in the long run because we have a huge building and a few of these rolls that we had to install. Luckily the building is 30 meters long, at least on the inside, and the rolls are also 30 meters long, so we almost had no cutoffs. And the manufacturer, Gefinex, they also have a radon-proof version. And there you're not concerned about water entering your house, but a radioactive gas. Because radon occurs naturally. It can happen underneath your house. You have to ask your geotechnical engineer if there is radon in the area. And then you have to protect your house from that gas. Because once it enters your house, it will stay around in your basement. And then suddenly you're surrounded by radioactive gas, and you really don't want that, especially in your house where you stay for a long time. So that's why you can get this stuff as radon proof, and then you can save yourself even from that. But I didn't care about radon, I was only concerned about the water, and this really gives me a peace of mind that everything will be waterproof from now on. And it was also very easy to install. It took us about 1.5 days, and after that we could start laying down the rebar, and boy did we add a ton of rebar. More than a ton, several tons. This will be a very sturdy foundation where heavy machinery can drive over it. And I could barely lift these sheets, so we had 4 or 5 people lifting them in one by one. And after the first layer of rebar was installed, we marked all of the positions for the steel beams for the steel building that will be added later on. And we also marked all of the rooms, the kitchen and the showers and so on, so we could add radiant heating zones to those specific rooms. And then I took the drone and used that to double check all of those markings, because I could just put this in Photoshop, overlay the original plan, and then I could see if I had made any mistakes, because they will receive very long bolts that would go otherwise into this radiant tubing. And this is the tubing that we're using. It's 20 millimeters on the outside and 60 millimeters on the inside. And we strapped this down with these zip ties. And that took a whole day with 7 people. Special thanks goes out to my friends Sarah and Marcel. They showed up on short notice and helped out that day. That was really, really nice of them. I bought 4,000 of these zip ties, and they are green, so you can easily spot them and see where you missed some. And they are 200 millimeters long, and that's exactly the spacing between 2 lines. So we can just put them next to the lines and see if the spacing is correct, and then tie everything. And that really helped, but it was still so much work. That's why I didn't have time to film this whole process, but we got it done, and now we have radiant tubing every 20 centimeters, and that will be incredibly efficient in combination with the heat pump. More on this later when I install the heat pump. Just for now, we installed only 100 meter long loops. None of the loops are longer and none of them are shorter. They are all exactly 100 meters long. And they even fit inside those zones. So each of these rooms can have their own temperature setting later on, and that will be very, very efficient. There are some larger gaps in between the pipes, but I don't care about that. As long as there's warm water flowing through this, the slab will get warm and ultimately the building will be nice and warm. Afterwards, I also double checked and made sure that none of these loops are underneath any areas where we have to drill very long bolts through the concrete. These manifolds are all made from brass, and they're very high quality and heavy duty and really big in size. Everything on here is 1 1/4 inch diameter, so that way we can get a lot of water through this. And right now I need to attach everything to here. So first I'm going to attach these ball valves. They're nice later on to isolate the circuit for maintenance, for example. But right now I need to close off this end and this end. They're both threaded, so we can pressurize the whole system. And we have 3 manifolds in total, so I bought 3 pressure gauges and also 3 compressed air inlets, and I will attach them right now, and then we can pressurize everything and check overnight if the pressure is holding. These are the compression fittings. They go in here. They're called the Euro conus, so it's a tapered little insert in there, and that gets pushed over the little plastic pipe, gets in there, and then this thing will push everything in there and make a waterproof seal. These are little dials, and they show you the flow, the rate of flow, so between 0 and 3 liters per minute. And underneath these caps, right now, they just act as a valve opener. But on here, this is a little valve. You have to push it in with quite a lot of force. On here, we put some motors later on, and the motors will electrically push them down. The pipes are connected to the manifolds with these Euro cone fittings, and this one fits really nicely, but this pipe had some tolerances and nothing would fit. This is such a waste of time. This is the normal tube with the normal diameter. This is the same tube. It's just the other end. It's 200 meters later and it's much too thick. So I bought this adapter. This could barely fit in here, but it fits super easily in here. It's far too loose. So I got this piece of bronze and I'm going to turn this to make something like this, just with 2 different diameters on the outside. I was a bit fed up at this point because the weekend was really physically strenuous. All this kneeling down and getting back up. We installed 3,400 meters of this tubing, so we were all day long kneeling down and getting back up to install the next zip tie. And my legs were really sore by this time, and I didn't want to do any more work on this. But I'm happy with this connector. I don't think I could have bought any better connector in a hardware store. I mean, the diameter is reduced a little bit now, but it's just a very short length, so I don't think it matters overall. And this is above the concrete, so I can still service it later on. Today the wind has finally died down, and I bought some end caps and gaskets, and I'm sealing off the unused circuits because otherwise I can't pressurize it. And I want to pressurize all of this to make sure there are no leaks, because this will be literally set in stone. Of course, I found some leaks, but only at the screw connectors, so that was easy to fix. None of the pipes were damaged, and I heard that the installers that do that every day, they never damage any of the pipes. So this is where we are at. We've got our insulation, we've got the first layer of waterproofing, we've got our radiant heating tubes all the way across the workshop, and we've got our second layer of rebar on. No, so now I can walk on this. And I'm sure the question will come up, can you drill into the radiant heating? You can if you have a really long drill, but you don't need such a long drill. They are 60 millimeters below the second layer of rebar, and that is 60 millimeters below the concrete. So we have 12 centimeters in total, and none of the bolts that we need are that long. So as you just saw, we put a ton of details in this foundation. The insulation, the waterproofing, the rebar and the radiant heating, and they will all work together to form a very functional foundation. We used a lot of energy to build this, but from now on it will save a ton of energy every single year for many decades. So I guess overall it will save more energy that was consumed to build it. And I think that way it will be sustainable. This building definitely exceeds any of the government regulations here in Germany, which are quite strict for energy saving. So I think we're on the right path, but of course this won't be perfect. I mean, the best alternative for this would be to not build a building at all, but that's just not practical. We need to draw the line at some point, and there is no good replacement for concrete. So you always have to do compromises, and at least I'm very confident that we did the very best with these materials that we could. This is an amazing foundation. It will be very energy efficient, and because it's of such a high quality, this will last for many, many years and decades. So the energy consumption for building it will be offset over the very long use time that this building will have. This frame is where the showers are going to be, and we added less concrete here so we can later add some slope so the water drains into these pipes. The pour itself was very smooth and efficient. We had 4 trucks, I think, and they kept going back and forth between the site and the concrete plant. And I think we had 15 trucks full of concrete in total emptied onto the pad. And while they were pouring, they also leveled all of the concrete with a float. And that was just a rough job. I mean, this is not perfect, but it gets all of the aggregate down deeper inside of the concrete, so the rocks are not sticking out of it. And of course, they also vibrated everything to make sure that it's a very dense concrete. And just after the pour, it started raining really heavily, but only very shortly, so that was okay. And at 2 o'clock, the company SPG Betonglatten arrived, and they were there to polish the concrete and to add this stuff. This is a hardening agent, and that will make a very hard concrete surface that's abrasion resistant. So you can drive over this with a forklift for many, many years without destroying it. And it looks like cement, but I think these are just very hard rocks, similar to what you have on sandpaper. And they spread this out in fine layers, and they let it soak for about 20 minutes, so it absorbed all of the moisture from the concrete. And then they worked it in using these power trowels. So this is like troweling by hand, just much quicker because it's powered and you can ride on it. And they did a fantastic job. It was a crew of 4 people, and they arrived at 11 o'clock, I think. First they had lunch and slept for a few hours from the last day's job. And then they started working at about 2 o'clock in the afternoon, because they always have to wait for the concrete to harden. But they also have to make sure it's not too hard and not too soft. So they were kind of on standby all day, and they only worked in short shifts of maybe 10 or 15 minutes, and then they had to wait for another half an hour. They were extremely skilled, and they had a great work ethic. I mean, they really got the job done. Despite the weather, despite the cold, they were there all day, and they did a fantastic job, and they really went above and beyond to get a perfect finish. I was also there all day, but only to watch them and to keep them a bit of company. I got them dinner and some coffee, and they were happy to keep working. And over the hours, you could see how the concrete kept improving. It got smoother and smoother. And this will be the final finish that we're going to have on this concrete. I will not add any epoxy, because for that you kind of have to sandblast it with little metal beads to get rid of the residue that happens when the concrete is cast. And I think epoxies are necessary. This concrete is just good enough. It's much harder, it will last longer, and it doesn't look as beautiful at the beginning, but then you also don't have to care for it as much as for nice epoxy. And it got smoother and smoother, and suddenly there was a really big change. On the right it's matte, but here it's shiny. And I'm gonna try it. Oh wow, this is so smooth. This is like a tile. It's so smooth, it's like marble almost. Wow, it's a little bit matte, but it's hard and it's smooth. It's amazing. Wow. Wow. They kept polishing throughout the night, and they only finished up at 3:30 in the morning. I returned the next morning, and everything was beautifully polished and really, really smooth. It feels like a giant piece of tile, and this is the best outcome that I could hope for. It's not shiny, but it's really nice. Over the next week, I kept watering the slab, and that mitigates the cracks from forming. I'm not sure if I will be successful long term, but I don't really care. It's a workshop and I don't have these super high standards for the look of the floor. That makes everything much easier. These pipes are for the shower drains, and I had troubles in Germany finding a shower drain that fits inside of the pipes. I could only find some with bigger diameters and they go on top of the pipes. So I had to take off a little bit of concrete to make room for them and to keep them low enough so we have enough slope so the water can flow nicely into the shower. I don't want to have any curb in front of the shower, so I want everything to be in one plane. And this was easy enough. I just sawed this off and then I smoothed it out with the angle grinder. And then I had enough space to fit the shower drains so the water can nicely flow into the valley. So that's it for this week. Thank you very much for watching. Please subscribe so you don't miss out on the future videos, because next we will install the actual steel workshop and that will be quite exciting, I think. So stay tuned for that, and thank you very much for watching, everybody. My name is Max Maker and I make all kinds of stuff.